My name is Maciej Malecki. I work for a Node.js hosting company called Nodejitsu. I write code, I talk to servers for fun and for profit. My GitHub is Malecki. There's my Twitter too. I have an email, which I tend to ignore. Anyway, so do you guys see this? Is this a good background color? Can you see the image? Well, you have to believe me. It's the T-shirt by Substack, the one with turtle strapped to a rocket, which I unfortunately left at home. Okay, so the first thing, when you go to nodejs.org, the homepage of Node, you see those words, which someone already mentioned here. Dominic Tarr, I think. Shit, Ryan Dahl says. Node.js is a platform for easily building fast, scalable network applications. It sounds like magic, right? It's like Node makes your application go like a turtle strapped to a rocket, which isn't entirely true. It sounds like magic, but it really isn't magic. You still have to do some work to make that actually happen. So, right, so when I got into Node, I was told that it's like blazingly fast, that I don't have to pretty much do anything. I can just make it work. Well, this is partially true, because there are many things which Node is really faster at than conventional languages like C. It's really more about model of performing I/O operations. So yeah, it's fast. Okay, I would just believe it. Node.js is not the silver bullet. So I work for Node.js, so I talk to people pretty often. This part of my job. So once I heard that there's a guy who wanted to rewrite his whole Ruby on Rails application because it was really slow. So he started it. He wasted like a week of time, and then he got fucking nowhere. It turned out to be pretty much as slow as his Ruby on Rails solution, which wasn't that surprising to me, because it doesn't really matter what language or framework you're using. If your code is shitty, then you probably will fail. If your solution stack is shitty, then you'll probably fail. Yeah, but there are a few things which are really faster at Node. Like I/O Node is comparatively faster than other languages. That's related to how Node.js performs I/O operation. Every I/O operation, for example, well, file read or something like that, at least on Linux system. On Windows, it's some crazy stuff, but like Windows, who the fuck cares about Windows, right? Sorry, guys running Windows, I like you. But anyway, so everything is performed in parallel in a thread pool, which is maintained by libv. So this is the layer which sits right down under Node and performs the actual hard stuff in Node. So yeah, this is a great work by Ryan Dahl, Ben Nordis, Bird Builder, and the whole core team. This is really awesome. Anyway, this is why it's faster. Network operations are also faster, but it's a bit more complicated. It's related to how Unix handles I/O operations. Okay, so next thing, V8 is fast. I watched Felix talk about writing parsers in JavaScript. I was really surprised. He showed a few dirty tricks, which I wouldn't really dare to use in production code. But the fact is, V8 is really, really good at making your code go really fast. This is the thing which makes Node really awesome. V8 was originally built to be used with Google Chrome web browser. So Google made sure it's really fast. Google hired engineers, compiler engineers, whatnot, to make sure it's really fast. So yeah, this is one of the pros of using Node. V8 is really fast. Next, you guys probably don't see that, do you? Okay, great. So yeah, your code matters. It's not like, as I said, you can't really make Node.js go just like a turtle strapped to a rocket without putting at least some attention to it. Mainly because you can write shitty code in every language and every framework. I've seen beautiful code in Ruby. I've seen beautiful code in even CoffeeScript. Like, really, this sometimes happens. I was pretty surprised, but I did. I couldn't really read it, but it looked nice. Yeah, I've seen beautiful code in C. libuv is the example of great code and great implementation. So yeah, but the point is, you can write shitty code in every fucking language and every framework you want to use. It's not like Node is the only thing. Okay, so benchmarks, motherfucker. Do you write them? So the thing I got to just recently, I started writing benchmarks and started actually benchmarking our production services to get to know where we actually spend time, what do we actually do, and this got me to some really good, just few optimizations, and I think it made me a better programmer. But the point is, just as Felix said, don't assume that your code is fast. Just benchmark it. Try various optimizations. Try things. It's about having fun. Okay, yeah, figuring out what's slow is important. I'm going to show you guys one thing, one email I got. Just when I began working at Nujitsu, is Dominic? Oh, Dominic is here. Okay, great. So, yeah. Okay, there are many causes of, I'll get to you, Dominic, in a few seconds. There are many causes of Node applications and generally applications being slow. There's too much I/O, too much input-output operations, which shouldn't really surprise people. Ryan Dell had this table of I/O latencies for various accesses. So like L1 cache was, I think, the fastest one. Then there was RAM memory. Then there was disk access, and then network access. Network access was too slow. And the next possible cause of slowness in Node and generally every program is CPU-bound operations. So operations which generally rely on performing computations, just like the famous Fibonacci code. It was, yeah, this dude was wondering why did it make his node slow? Well, you shouldn't really compute Fibonacci in Node, and well, if you do, don't publish a blog post about it because you're a douche. If you actually want to perform CPU-bound operations in Node, you should either, if you know what you're doing, go down to the libuv level and write a worker thread, or write worker process. This is popular in many languages. Okay, so yeah, Dominic Tarr. Dominic is awesome. He's like a really great guy. He knows how to write code. He also knows how to drink. He slept on my couch for three weeks. I really loved it. I loved discussing things with him. Anyway, this is an email I got right after I started working at Nujitsu. It was like a year ago or so. So this mail says, "Hey, so I've been writing the load balancer. How badass is that? And some stress. Oh fuck." And some stress testing. And it's looking like it's performing about 10 times faster. So I'm like, oh, wow, that's pretty cool. Yeah, so then Dominic actually showed us graphs. This is how you're supposed to do that. If you want to prove that your thing is faster, you should just show me some graphs. So as you can see, this is a response time graph for our load balancer, the one which Dominic ditched. I will explain why does it look like that in a few seconds. Anyway, you can see that a request takes at least 100 milliseconds, and then as number of users grows and as time goes, well, response time just gets worse and worse, really unstable too. This obviously wasn't a good thing for a platform as a service, right? Okay, and the new load balancer, which Dominic wrote, you can see how number of concurrent users rises. and this thing just responds in under 80 milliseconds. How awesome is that? So our problem was that with every request, every HTTP request we got, we queried the CouchDB, our production CouchDB, to ask for which IP should the load balancer redirect traffic to. So obviously we got into too much I/O operation situation, where we wasted time just querying the couch and waiting for results. Well, to be fair, in every another language, if you wrote load balancer in Ruby, which is kind of funny and silly, but if you were that stupid, we would just block whole thing for time as we wait for the CouchDB response. Right now, what we do is we cache everything. We just fetch whole database at the beginning. This is kind of memory expensive, but like memory is cheap. We fetch whole database and then watch the changes feed. So we don't have to query CouchDB at all anymore. We only watch for changes. Okay, so next thing, I showed you how you should benchmark things, but now about profiling. So profiling is a process of watching your application in real time or not, whatever. Watching it perform certain operations, and seeing what can be improved, where the application spends its time. This is really important. If you get a chance to try that in production, you probably should. You will get some really interesting results. Okay, so how can you profile your Node applications? This has been always very hard to do, and certainly not another thing everyone can do because of how Node works. Everything is asynchronous. You can't really like put a console log. This is where I started. This is where I finished some operations because of the nature of Node. So you can. There are basically 3 solutions I know of. There are probably many more. So dtrace. Dtrace is fucking awesome. The thing is, you can only use it on SmartOS, which is kind of a downside, but not really, since SmartOS machines are really cheap when you get them from Joint, and you can run it locally. That's not a big problem. There's Node Time, which is pretty awesome. It's an in-process monitoring tool which does some monkey patching, and obviously logging. You can just log times of operations if you get a chance to it, because as I said, it can be hard. Anyway, dtrace. It makes me really happy. It kind of saved my ass a few times in production when we were running into problems with some weird calls, weird system calls going out from balancers, resolving not the host it should resolve to. Okay, so now I will show you one of the most awesome features of dtrace, which is flame graphs. Okay, let me get this up. Oh wow, I got a tweet. Cool. Okay, cool. Love ya. Anyway, oh wow. Okay, this is my talk, and I'm going to make this a bit bigger. Okay, so I have Fibonacci server. I have actual Fibonacci server running in here. It's like a recursive Fibonacci, but why am I doing this? I will explain this in a second. So I'm going to launch this thing right now and benchmark it from the same host to make it faster. If I benchmark it from conference Wi-Fi, I would probably break things. Anyway, I wrote this script. You type in host name and profiles it remotely. This is pretty cool. Anyway, I'm going to hit this thing. The server is now being benchmarked. This will take some time. This takes at least a minute because you have to gather data from dtrace, and 1 second of benchmarking isn't really enough for me. You can see that dtrace is running remotely on the server. Also, dtrace has this awesome capability of going into a process and getting its stack, JavaScript stack, actual JavaScript stack, which is actually executing at the moment. This is one of the most awesome features of dtrace, and also SmartOS, because SmartOS debugger can do that too. Come on. Okay, I can see that it finished benchmarking. It does 65 transactions per second, which is pretty good for a Fibonacci server. Obviously, I'm going to put a blog post about that and say that Node is so slow. Is this beer? Okay. Come on. Okay, it's fetching it. Okay, great. So yeah, I fetched this. I'm not sure if you guys seen that before, but here's the actual flame graph of my Fibonacci server running on this SmartOS machine. So as you can see, there's all this C crap in here, which is most likely V8, then HTTP parser, then again Node. And here's my actual Fibonacci function. You can see as the recurrence goes, again in here, we get from the biggest value to the smallest one. This was starting at 20. So yeah, there you go. This is the whole stack of operations executing every request. How awesome is that? You can read what your application is actually doing. It's really important when you analyze this kind of behavior when your server goes slow. You can actually see where your server spends time. This is really awesome when you develop Node Core too, because you get the whole C++ stack, which doesn't really happen. Have you ever seen like C++ stack and JS stack together? I don't think so. At any rate, yeah, dtrace. Okay, nodetime.com. It's really cool too, but it's not what dtrace is really. It's like a bit higher level. You can really get as deep as dtrace goes. This is an example graph from nodetime.com where you get response time histogram over function of time. Oh fuck, I'm running out of time. Okay, logging, one of the methods of profiling I mentioned. Disha wants you to log. He definitely wants you to log. He will use the unicorn if you don't, so you better do. What we do is sometimes when we have a heavy function, we just put a timer in front of it and then take the time when the function is done. It's the simplest method of profiling. Okay, next thing, benchmarking. Benchmarking, as I mentioned before, but this is a bit more detailed information about benchmarking. Benchmark in actual environment your thing is going to run in. So many of you probably seen blog posts about benchmarking Java versus Node versus Ruby on Rails versus Sinatra versus blah, blah, blah versus... only thing that's missing is CoffeeScript. I am fucking CoffeeScript benchmark. Anyway, if you plan to run your application on an actual server, get a staging server, get a test server, and test it there. Don't test it on MacBook Air, because how laptops work is they scale CPU. So if you get computation heavy thing on a MacBook Air, it would just bump up the CPU, and well, it won't result in detailed benchmarks. Next thing, forget micro benchmarks. So yeah, hello world benchmark. How many of you have seen that? Please raise your hands. Yeah, probably too many. Anyway, and if you blog about such a benchmark, you're a douche. Don't do that. Don't compare Java and Node hello world. It's not going to work out, and you're going to get trolled on Twitter. Anyway, this is the classic hello world server I wrote. Like everyone starts from that and knows probably. It can handle over 2,000 requests per second on some SmartOS server. And this is optimized server, hello world server, which, so why do we create a buffer here? The thing is, when you write a thing to a string to a network socket or to a file in Node, it has to be first converted to a buffer, which is just like a block of data not located in the V8 memory heap. And it does that every time I write the hello world string. So this can get pretty expensive. Anyway, here I create a buffer beforehand, and I get 1,500 requests per second more. So it's really easy to cheat the system. It's really easy to cheat like that. Okay, so yeah, I'm going to tell you one thing, guys. Spoiler: nobody fucking cares about micro benchmarks. Like, really, don't do them. Nobody really fucking cares about Hello World, how Hello World is fast. When you want to do an actual benchmark, please do a benchmark on an actual environment. Please benchmark your production server even. I do that all the time. I only broke it twice. Okay, anyway, so do we have time for questions? Okay, so no questions, guys, sorry. I get 2 minutes left anyway. Okay, so this is all. Thank you very much. I hope you guys had a great time.